Hey everybody, welcome back to our statistics series. In this video we're going to be looking at section 1.4, which is other effective sampling methods. Last time we talked about simple random sampling, but some populations are just too large for simple random sampling to be practical. So there are other sampling methods that researchers use to collect a representative sample from their population. And the methods we're going to be talking about today are stratified samples, systematic samples, and cluster samples. First, let's talk about stratified samples. You know, the word stratified means separated into layers. A stratum is a layer. So a stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from within each stratum. The individuals within each stratum should be homogeneous or similar in some way. So take a population like the one here. We could, for example, separate that population into women and men, and then do a simple random sample to choose some of the men and some of the women. And so the population gets separated into strata, and from the strata we choose members to become part of our sample. Now I want you to notice that this sampling method still is based on the simple random sample. And so you might ask, well, why bother, if we're still going to do a simple random sample, why bother to split the population into these groups? Well, it may be that the population as a whole is just too large to manage. Or it may be that you want to make sure that every group within the population is fairly represented, and separating the population into groups allows you to control what percent of the sample each group makes up. Now, stratifying could mean separating the population into men and women, or freshmen, sophomores, juniors, and seniors, or unmarried people, married people with no kids, married people with kids. There are lots of different ways that you could separate a population into strata, and it really depends on what you're going to use the sample for. Now, the proportion of each stratum should be the same in the sample as it is in the population. For example, suppose the strata are freshmen, sophomores, juniors, and seniors. If the population is 32% freshmen, then the sample should also contain about 32% freshmen. Remember that within each stratum, simple random sampling is used to choose members of the sample, so a frame would still be required for this kind of sample. Okay, let's take a look together at example 1, obtaining a stratified sample. So read the situation first. It says, the president of a university wants to conduct a survey regarding campus safety. The president divides the community into 3 groups: resident students, non-resident, commuting students, and staff, including faculty, so that he can obtain a stratified sample. Now notice that these groups are homogeneous, meaning that they all share a very important characteristic. The resident students who all live on campus, the non-resident students who are commuting, and the people who work there. So suppose there are 6,204 resident students, 13,304 non-resident students, and 2,401 staff, for a total of 21,909 individuals in the population. The president wants to create a sample of size n equals 100, with the number of individuals selected from each stratum weighted by population size. How many people should he choose from each stratum to make up his sample of 100 people? Well, remember that each group's proportion in the sample should be about the same as that group's proportion in the population. So what we need to do is find out what percent of the population each of these groups makes up. And let's start with resident students. Now we know that there are 6,204 resident students, so the proportion of the population that they make up is 6,204 divided by 21,909. So the proportion is 0.283, or if you want to think in percent, you can say 28.3% but whenever we calculate, we have to remove the percent symbol anyway, so you may as well just stick with this proportion number. So now take the proportion and multiply that by the sample size that you want. And so 0.283 times 100 gives us 28.3 people from the resident student stratum. Now, two things. One, we have to round this number because you can't have 28.3 people. It has to be a whole number. So let's round that off to 28 resident students. But the other thing I want to point out is it's sort of a coincidence that these two numbers are the same. This is the percent. The reason this number is the same is because we happen to be obtaining a sample size of 100. So if we needed a sample of any other size than 100, this number would be different from the percent. Okay, now let's look at non-resident students. The proportion of non-resident students is 13,304 over 21,909, so that proportion is 0.607, which would come to 60.7%. And so let's take our 0.607 and multiply by our sample size, which is 100, and we have 60.7 people, which rounds to 61 non-resident students. And then let's do the staff. We have a staff of 2,401 divided by 21,909 in the population, and that gives us a proportion of 0.1096 for our staff. Now, I kept an extra decimal here because I wanted to make sure you understand what's going to happen here. The 6, when we round off, is going to cause the 9 to have to be rounded up. And because this 9 is the last digit, when you round a 9 up, it goes to 0. And just like an odometer on a car, that's going to make this number turn to 1. So we're going to have 0.110 as our proportion of staff, and that's equivalent to 11%. And so we'll take 0.110, multiply that by 100, and we find 11 staff. And now just verify that 11 plus 61 plus 28 adds up to the 100 people that we wanted in our sample, and it does, so we are good to go. Now here are a few advantages of stratified sampling. Stratified sampling may allow fewer individuals total to be sampled while obtaining the same or more information, because one reason you may need a larger sample is to make sure all the groups get adequate coverage. If you are controlling that through the stratifying, then you may be able to get away with a smaller sample overall because you know that each group is represented properly. And that's another advantage. This guarantees that each group is represented properly. The researcher can determine the characteristics of the strata, so the researcher can decide how they want the strata divided up. And then, if they want to, they can analyze the data to find differences between the groups because they have them broken out by groups. So it just gives us more information overall. But it's very important to remember that this method is still based on a simple random sample. Even though the researcher gets to decide how the groups are broken out, within each group we still have to obtain a simple random sample. And that's very important because randomness is what makes each of the sampling methods in this section valid. Our next sampling method is called systematic sampling. A systematic sample is obtained by selecting every kth individual from the population. So you start by choosing a random number between 1 and k, and then you include that person and then every kth person after that. So if you look at this picture, you can see that they're choosing every third person. So they randomly chose a number less than 3. So they start with person number 2. That 2 was randomly chosen. And then after that, they just do every third person. So 2 plus 3 is 5, and 5 plus 3 is 8, and 8 plus 3 is 11. And so after number 2, every third person after that becomes part of the sample. Now, of course, that's just an example. We don't have to have k equal 3. K can be anything we need it to be, and therefore the starting place can be anything we need it to be that's less than k. So a couple more points about systematic sampling. If there's no way to get a frame of your population, this is the best method to use. because every other method we have requires some kind of frame. And this is a random sample, but notice that it is not a simple random sample because every group of size n does not have the same chance of being selected. So let's look at this. Group 1, 4, 7, 10 had the same chance of being selected as group 2, 5, 8, 11, but what about group 1, 2, 10, 11? That group had absolutely no chance of being selected because those people are not an equal distance apart. So that completely ignores K, and so that keeps this from being a simple random sample, but there is some randomness built into it because even though K itself is not random, the choice of 3 here should be by design. But the starting place, remember we have to randomly choose a starting place that's between 1 and K, that number should be randomly chosen. So there is some randomness here. Now let's see if we can get our own systematic sample. This says the manager of a Kroger store wants to measure the satisfaction of the store's customers. Design a sampling technique that can be used to obtain a sample of n equals 40 customers. Now the problem with trying to sample the customers from a store where you just walk in like Kroger is that they cannot give you a frame of their customers. So really systematic sampling is about the only kind of sampling that we can use on a store like this. So what we're going to do is just choose a number to be K. Right now we don't have any way to know what would be a good choice for K, so let's just do this. We could start with the 5th customer and survey every 10th customer until we have 40 people in our sample. Now if we do that, then the first person in our sample, subject number 1, will be the 5th customer, and then if we add 10 to that, subject number 2 will be the 15th customer, and then if we added 10 to that, the 3rd subject would be the 25th customer. And we could just keep going until we get down to the 39th subject, and that would be the 385th customer, and then the 40th subject would be the 395th customer. And I know you're thinking, I don't want to have to add 10 over and over and over again. There's got to be a way to know which customer without having to just add 10 and add 10 and add 10. So that's one issue we want to clear up. We need a kind of a shortcut or a formula way to calculate which customers we get. And we also need to talk a little more about K and decide whether 10 is a good number or not. Here are some possible drawbacks to guessing at K. First of all, if K is too large, we might not be able to get n people in the study. Imagine in our example, if we had chosen K to be 50, then we would only be able to interview every 50th customer, and the day might end before we were able to see enough customers to get 40 people in our sample. So we don't want to choose K too large. On the other hand, if K is too small, we might get n people well before the day is over, and we might leave out the shoppers from the end of the day. What if I had said, well, let's let K be 3, and we interviewed every 3rd customer? We might have our sample filled up before lunch, so we don't want to do that either. We kind of want to get K just right. And it would help if we had an estimate of capital N, the population size, so we could do a better job of choosing the right K. Here is the method that's actually used for obtaining a systematic sample. If possible, start by approximating the population size, capital N, and then decide how big you want the sample to be, so that's little n. Now if you divide the population size by the sample size and round down to the nearest integer, that will be what we use for K. It's important that you round down. Notice that you're not rounding to the nearest integer, you're rounding down to the nearest integer. So even if K came out, say 21.8, I still would round down to 21. Now if you don't know a number for capital N, then you'll just have to choose a number for K like we did before. Alright, after you have K, then you want to randomly choose a number between 1 and K. You could do that with a random number table, or by drawing a number out of a hat, or you could use the calculator, but you need to randomly select it, and whatever that is, we'll call that number P. Okay, now that we have P and K, this is how we get the sample. The first subject is number P, the second subject is P plus K, the third subject is P plus 2K. Notice that for each subject, I'm adding one more K than I did the time before, but it's always one less than whatever subject we're on. So when we find the first person, we don't add K at all, 0 Ks. And when we find the second person, we add 1 K. And when we find the third person, we add 2K. And when we find the fourth person, we add 3K, and so on, till the last person in our sample will be P plus N minus 1 times K, because if we're going to have N people, then we only need to add N minus 1 Ks to that. And what this does is this allows us to calculate the number of any person in the sample without having to know the one that came before. As long as we have P and K, we can find any person we want to find. Now we're going to do an example together where we're going to be given P and K, and all we have to do is calculate the position of each subject in the sample. So let's read it together. It says a salesperson obtained a systematic sample of size 30 from a list of 750 clients. To do so, he randomly selected a number from 1 to 25, obtaining the number 16. He included in the sample the 16th client on the list, and every 25th client thereafter. List the numbers that correspond to the first, second, and 30th subjects. Okay, so I hope you can see that we were given P and K here. We don't have to calculate them ourselves. He's going to be choosing every 25th client, so that number is K, and he's going to be starting with the 16th client, so that number is P. So actually, the first subject is easy because they gave it away. The first subject is client number 16. To find the second subject, we just need to add 25 to that. So the second subject is number 16 plus 25, which would be number 41 on his list. Okay, now let's go ahead and get the third subject. They didn't ask for the third subject, but I think it would be a good idea to do it just to make sure that you see the pattern here. To get the third subject, we could add 25 to this number, but we don't want to put ourselves in a position where we have to know the previous number to get the next number. We would like to be able to calculate the position of any subject without having to know the number that came before. So let's just stick with P and K. In order to get the third subject, we need to do number 16 plus 2 25s. So I'll write 16 plus 2 times 25, and that's going to be client number 66. So the third subject in our sample is client number 66. And now let's skip on down to the 30th. And now let's skip on down to the 30th subject in our sample. To find the 30th subject, how many K's should we add? Well, see the pattern here. For the first subject, we added 0 K's. For the second subject, we added 1 K. For the third subject, we added 2 K's. So the number of K's we add is always one less than the subject we want. So if we want the 30th subject, we should add 29 K's. So that's going to be 16 plus 29 times 25, and you can do that on your calculator, and you'll get client number 741. And now let's look at an example where they have not given us K and we have to find it ourselves. So it says, to predict the outcome of a county election, a newspaper obtains a list of all 1,520,485 registered voters in the county and wants to conduct a systematic sample with a sample size of 160. If we start with the 5th voter on the list, what will be the 4th, 5th, and 7th individuals in the sample? You notice that they gave us a P number, but they have not given us K. So we'll have to calculate our own K. And so what we want to do is take the population size and divide that by the number of people we need in the sample, and that gives us about 9,503.03. And remember, we always round down, because the problem is that if you rounded up, you would run out of people in your frame before you got the number of people you needed in your sample. So we always round this down, even if it's greater than 0.5. So we're going to go with K equals 9,503. Okay, now we can calculate the fourth subject, the fifth subject, and the seventh subject. So remember, we're starting with the fifth voter on the list. So the fourth individual in our sample is going to be 5, because that's our P number, plus 3 times 9,503. Remember, this number we multiply by K is always one less than the position we want. And so that would be voter number 28,514. Okay, so the fifth individual would be 5 plus 4 times 9,503. And that's going to be voter number 38,017. And the seventh individual would be 5 plus 6 times 9,503. And that's going to be voter number 57,023. So just to recap, advantages of systematic sampling are that it's easy to employ, it's relatively inexpensive, and it can be used in situations where a frame is impossible to get. Although, as we just saw in the last example, you can also use it in a situation where you do have a frame. Now let's talk about cluster sampling. A cluster sample is obtained by dividing the population into heterogeneous groups that we call clusters, and then we randomly select some of the clusters, and then we include all members of the selected clusters in the study. Okay, so here's a little picture to help. We have a population. We divide the population into heterogeneous groups. Now this is different from a stratified sample, because remember, in stratified sampling we divide the population into homogeneous groups where they all share some major characteristic. But in cluster sampling, we're dividing the population into heterogeneous groups. So each group should be pretty similar to each other group. We randomly select some of the groups, but then every member of the selected groups becomes part of the sample. Notice that if we selected this group here, all 4 of the people in this cluster would become part of the sample. Okay, so just to make sure that you're clear on the difference between cluster sampling and stratified sampling, let's think about it. In stratified sampling, the population is divided into homogeneous groups, and the members of each group share some important quality. But in cluster sampling, the population is divided into heterogeneous groups, and the members of each cluster form a miniature model of the population. In other words, each group is pretty similar to each other group. Okay, here's an example for us. A sociologist wants to gather data regarding household income within a small town. Suppose there are 25 neighborhoods in this town. Obtain a sample using cluster sampling. So we could choose to let each neighborhood be a cluster. Now, again, this is one of those situations where this is not something I expect you to be able to come up with on your own. It's just a situation we're going through together. So we could choose to let each neighborhood be a cluster, and then we could number the neighborhoods from 1 to 25, and that's basically our frame. So here it is, I've drawn it out for us. So each of these neighborhoods represents a cluster. We're going to randomly choose a certain number of clusters. Let's say 6 for this example. Okay, so I'm going to get my TI-84 out and generate a 6-number sample for us where all the numbers are between 1 and 25. And what I'm getting is 7 and 11 and 12 and 20 and 18 and 16. Now, of course, if you generate a 6-number sample on your TI-83 or 84 calculator, you're not necessarily going to get the same numbers I did, and that's fine. That's because it's a random sample, so everyone really should be different. And what we would do now that we have these 6 clusters randomly chosen is every person that lives in each of these neighborhoods would become part of our sample. So survey every household within these 6 neighborhoods. So the random part comes when we randomly choose a few of the clusters, but then every individual in each cluster becomes part of the sample. Okay, here's just a little more information about cluster sampling. Cluster sampling works best if the clusters are heterogeneous. Therefore, if the clusters are a little more homogeneous, as would be the case in a neighborhood, because let's face it, a lot of times people who are similar to each other live in the same neighborhood. So you may have a neighborhood where all of the people who live there are older couples, or you may have a neighborhood where all of the people who live there are younger couples, and certainly they're separated economically. So you're going to have neighborhoods with nice houses where lots of wealthy people live, and you're going to have neighborhoods with more average houses where lots of lower income people live. So we would kind of like to think that neighborhoods are heterogeneous, but they may be in reality a little more homogeneous than we would want for a cluster sample. So in this case, it's better to have more clusters with fewer individuals per cluster, and that way you get a better cross-section of the population. However, if the clusters are pretty well heterogeneous, then each cluster is a little miniature version of the population, and fewer clusters with more individuals per cluster will work in that case. Cluster sampling is good when the clusters are spread out geographically, because then researchers don't have to gather data from so many different locations, because travel between locations costs time and money. So in a case like this, where the clusters are spread out geographically, we really would want to have heterogeneous clusters so that once a researcher gets to a place, they can just interview all the people in that place and not have to travel to lots of places. A lot of times the purpose of using cluster sampling in the first place is to minimize travel. Okay, here's a little overview of sampling types, and these are all the ones we've talked about. First, we talked about simple random sampling, where we just have a group and we randomly choose people out of the group to become part of the sample. And remember, every sample of size n has the same probability of being chosen as every other sample of size n. Okay, then we talked about stratified sampling, where we divide the population into homogeneous groups, where each stratum shares some characteristic that's different from the others. And then we randomly choose people from those homogeneous groups to become part of our sample. Then we talked about systematic sampling, where we choose every kth person. And then finally we talked about cluster sampling, where the population is divided into heterogeneous groups. And then we randomly choose a few of the groups, but every member of the chosen group becomes part of our sample. So those are the 4 main sampling types that we usually see. This is probably a good place for us to talk about convenience sampling. A convenience sample is one in which the individuals in the sample are easily obtained. This is never a valid method. If researchers are choosing subjects for study based on convenience, the results of the study are meaningless. So here are a couple of examples. A researcher in a theme park who approaches only customers who make eye contact and smile is getting a convenient sample, because she only wants to talk to people who are going to be pleasant and accommodating and stop and talk to her and maybe tell her the things that she kind of wants to hear. And another example of a convenient sample would be a website that asks its readers to participate in a poll. So one problem here is that the website is not casting a very wide net. If they are only going to poll their readers, then they're not including in their sample anyone who was not already drawn to their website. Another problem here is that the people are placing themselves in the sample. And so you're not going to get a nice cross-sectional representation of any population. You're going to get opinions from people who feel strongly one way and people who feel strongly the other way, because that's who participates in polls. If the participants can place themselves in the study, like we just saw, that's called a self-selected sample or a voluntary response sample. And it's just another kind of convenience sampling. And convenience sampling of any kind is never considered valid. And when you're watching TV or reading on the internet or maybe in a magazine or newspaper, watch for notation that says this is not a scientific poll. And what that means is this information was gathered by a convenience sample. People wrote in or clicked in or called in themselves, and the sample was not generated randomly. Therefore, you really can't draw any conclusion from it. Now, there's one more kind of sampling we want to look at, and that's multistage sampling. In practice, most large-scale surveys obtain samples using a combination of techniques just presented. So, say for example, you have a large national company that wants to conduct a national survey of their customers. The population of customers is probably still so large that any one sampling method would still be too difficult to use. So what they do is they use multistage sampling instead. And here's one example. Nielsen Media Research. These are the people who come up with the television ratings that decide whether shows get canceled or get renewed. And what they do is they ask people to put this little people meter on their televisions, and they put one on every television in the house, and it measures what program is being watched and who's watching it. And so now how do they choose which households to put the device in? They select the households with the use of a two-stage sampling process. And here it is. Using U.S. Census data, Nielsen divides the country into geographic areas that they call strata, and the strata are typically city blocks in urban areas or geographic regions in rural areas, and they randomly choose about 6,000 of the strata throughout the country. And then they send representatives to the selected strata, and they list the households within the strata, and then the households are randomly selected through a simple random sample. And so not only does that data determine what's canceled and what's renewed, but it also helps set prices for ads. So there's really a lot to this, and there's really a lot more to it than what we've seen. We've just gotten the basics on the four most common sampling methods, but large companies go a lot deeper than that, as we've seen here. And I hope you've also gotten the idea that any sampling method that's not somehow based on randomness is not valid and is not going to yield results that can be applied to anything.